Hello, welcome to this lesson. In this video, we are going to learn about probability of union. Okay, so assuming you have two events A and B, okay, we can see that the probability of event A or B, okay, which we can interpret as the probability of A union B is equal to the probability of A plus the probability of B minus the probability of what A intersection B. Okay, so you have to take note of this all that we have here. It is very important. Okay, so if you have to find the probability of event A or B, okay, it is the same as the probability of what A union B, and then that will be equal to what the probability of A plus what the probability of B minus the probability of what A intersection B. So let's take note of this. There may be a situation where the probability of what A intersection B will be 0. Okay, in that case, you're going to call the event A and B as what mutually exclusive events. So in that case, you're just going to have the union of the probability to be the probability of A plus the probability of B, right, minus what 0. There's no need for you to bring the 0 because it is just 0, right? So if you have a mutually exclusive situation, then that means that this part will be 0, okay? But if you don't have a mutually exclusive, then you're going to include it. So for us to better understand this, let's look at the example that I have here. Okay, so now let's look at this example that I have here. The question says that from the table below, what is the probability that a wafer was either at the edge or that it contains four or more particles? And then the second question says that what is the probability that a wafer contains less than two particles or that it is both at the edge and contains more than four particles? So let's look at how you are going to solve this question. So we have this table here, okay, which contains wafers that has been classified by contamination and then location. So you have the number of contamination particles from 0 to 5 or more, and then you have the location, which is center and then the edge. Okay, so assuming that we consider the column 1, okay, and then you have a value of 0, and then you are located at the center, you'll be given a probability of 0.3, and then if you are at the edge, you'll be given a probability of 0.1. Similarly, if you have a contamination number of 1 and then you are at the center, you'll be given a probability of 0.15, and then if you are at the edge, you'll be given a probability of 0.105. So that's the explanation for the table. Okay, and then we have the totals also there. So now let's look at how you are going to solve this question. The first one says that we should find the probability that a wafer was either at the edge or that it contains four or more particles. Okay, so let's go what you are going to do. Okay, so the first thing you're going to do is to find the two separate events in this case because you are applying the probability of union rule here. Okay, so let's find the two separate events. So the first event will be the question says that we should find the probability that a wafer was either at the edge, right? So this will be the first event was either at the edge. Okay, so you have a probability that a wafer was at the edge or it contains what four or more particles. So contains four or more particles or a wafer was what at the edge. So this will be the first event. So the first event which I'm going to denote with E1 will be wafers that are at the edge. Okay, so wafers at the edge. So that will be our event E1, and then event E2 will be wafers that contains four or more particles. Okay, so wafers that contain four or more particles. Okay. All right. So don't forget this all here. Okay. This all here means that you are applying the probability of union rule. So we want to find the probability of E1. Okay. Union what E2. Okay. And then from the addition rule, you can see that this will be equal to the probability of E1, right? Plus the probability of E2, okay, minus the probability of what E1 intersection what E2, okay. All right, so let's look at how we are going to solve this question. Okay, so what you have to do first is to find the probability of E1 and then also find the probability of what E2. Okay, so let's go ahead and then find the probability of what E1, which is the probability that a wafer is at the edge. Okay, let's look at that. So if you are looking at the probability that a wafer is at the edge, then you have to add all these probabilities, right? And then so you have to add all these probabilities, and then you know that their total is the 0.28 that you have here. So you're going to have the probability of E1 to be equal to 0.28. Okay, and then we have to find the probability of what E2 also, right? And then E2 is the probability that a wafer contains four or more particles, right? The probability that a wafer contains four or more particles. So let's look at that. So the probability that a wafer contains four or more particles, what you are going to do is that you are going to start from four, right? Because you're looking at what four or more particles, right? You're going to look at four up to five or more. Okay, so you are going to consider these two. And then we are looking at what the probability that what a wafer contains four or more what particles, right? So if a wafer contains four particles, okay, this will be the total probability, and then if a wafer contains five or more particles, this becomes the total probability. So we're looking at the probability that a wafer contains four or more particles, then that means that you have to sum up these two probabilities. Okay, so the probability of E2 will be equal to 0.05 plus 0.1, and this will give us a value of what 0.15. So that will be the probability of what E2, which is the probability that a wafer contains four or more particles. Okay, four or more particles. And then we know that what you have here is the probability that a wafer contains zero particles. This is the probability that a wafer contains one particle, a wafer contains two, a wafer contains three. But you want to look at the probability that a wafer contains four or more particles, which means that you're going to consider this two. Okay, so that's what it means. So now you know the probability of E1, we know the probability of what E2. What is left for us is to find the probability of what E1 intersection E2. So let's look at that also. Okay, so we are left with the probability of E1 intersection E2. Okay, so how do we get that? So you want to look at the probability that a wafer, okay, was at the edge and then also contains what four or more particles. Okay, you want to look at the probability that a wafer was at the edge and then contains what four or more particles. So let's look at that. So it's like that. Wafers that are in these two events, right? They are at the edge and also they contain what four or more particles. So what you have to do is that you are going to locate the edge column. Okay, you locate the edge column. Okay, and then what you do is that you're going to locate wafers that what are in the range of what four or more, right? So looking at four or more, we are going to have 0.01 and then 0.03, which is this and this. Okay, so these two probabilities are what are the probabilities for wafers that are the edge and also uh, contains what four or more particles. Okay, that's what this means. So to get probability of what E1 intersection E2, we are going to have 0.01 plus what 0.03, and then this will give us a value of what 0.04. So now you have all it takes for us to get our answer. So let's look at that. So you're going to have the probability of E1 union E2, okay, to be equal to the probability of E1, which will be 0.28, plus the probability of E2, which will be 0.15, minus the probability of what E1 intersection E2, which will be 0.04. So let's simplify this and see what you are going to get. So we have 0.28 plus 0.15 minus 0.04. This will give us a value of 0.39. So that means that the probability of E1 union E2, okay, will be equal to 0.39. That's how to apply the addition rule for probability of what union. So let's look at the second question also. Okay, so the second question also says that what is the probability that a wafer contains less than two particles, or that it is both at the edge and contains more than four particles? So just like we did for the previous one, you have to identify the two separate events in this case. So let's look at that. So you're going to get the first event, which is E1. Okay, so we are looking at the probability that a wafer contains less than two particles. Okay, so this is the first event, less than two particles, or that it is both at the edge. It is both at the edge and contains more than four particles. So let's look at the probabilities for these two separate events. So I'm going to let E1 be equal to a wafer that contains less than two particles. Okay, so let's look at that, less than two particles. Okay, and then E2, okay, will be equal to a wafer that is both at the edge, okay, and then contains more than four particles, and contains more than four particles, more than four particles. Okay, so the probability of E1 union E2, okay, will be equal to the probability of E1 plus the probability of what E2 minus the probability of what E1 intersection what E2, right? So all we want to do next is to find the various probabilities. So now let's focus on the probability of what event 1, which is that the probability that a wafer contains less than what two particles. The probability that a wafer contains less than what two particles. So let's look at the particles that are less than 2. We have 0 and then 1. So let's look at their probabilities. That will be 0.4 and then 0.2. So that will be the sum of those two will give us the probability of what a wafer having what less than what 2 particles. So for this, you're going to have 0.4 plus what 0.2, which will give us a value for 0.6. So now let's find the probability of what E2, okay, which is the probability that a wafer is both at the edge, okay, and contains more than four particles. A wafer is both at the edge and then contains more than what four particles. So now let's look at the edge column. We have this to be the edge column, okay. So you are looking at a wafer which is in the edge column and contains more than four particles, okay. So it contains what more than four particles. So looking at more than four particles, then we are going to have just what 0.03, okay. So that will be the probability of a wafer being at the edge and then having what more than what four particles. So for that one, we are going to have 0.03. Okay, so now let's look at the probability of what E1 intersection what E2. Okay, so let's look at this. All right, so now you want to look at the probability that a wafer, okay, has less than two particles, okay. It has less than two particles and also is at the edge and contains what more than what four particles. You are going to look at this intersection, okay. So what will happen is that you are going to consider wafers that has less than what two particles, right? So that will be from 0 to 1. So for that one we have up to this extent, okay. And then also we are considering the probability that a wafer is both at the edge and then contains more than what four particles, okay. So that one you are looking at just this value is at the edge and then contains more than what four particles. So that will be just this 0.3 here, okay. So what you are looking is that we are trying to see if we can get a wafer that will be in these two events, right? But looking at this will not be possible. This will not be possible because for the first event we are just looking at particles less than two, and then for the second event we are looking at what five or more particles. So you see that there is no way that these two are going to have some outcomes in common, right? Because 0 and 1. Okay, we are not even up to 5 or more, so we can't have a common outcome between the two. So in this case, the probability of A1 intersection E2 will be what? Equal to 0. So our probability, that is probability of E1 union E2, okay, will be equal to 0.6 plus 0.03. Okay, and then this should give us a value for 0.63. So this is a case where we have what? Mutually exclusive events. Okay, so that means that the probability of what E1 intersection E2 will be an empty set, which means that they don't have any outcome in common. Okay, so that's what this means. Thank you for watching this video.